We're going to look at lesson 7, sample variance and sample standard deviation. So we looked at measures of spread, and we looked at the range and interquartile range, but variance and standard deviation are a more standardized way to look at how spread out the data is. So the first thing that you do, we're going to find the standard deviation of some t-shirt prices. First thing that you do is find the mean. So what I did is I opened up the R code from the lesson, and then I am downloading the data as well. So while the R code here is loading, I'm going to take this lesson 7 data and I'm going to download it and then put it into R. So here I just go to, if you're in Google, you'd go to File, Download, and then download the Microsoft Excel file. And then in R, I need to import that data set from Excel. And then I browse, and it'll be in my download folder. If you have a Chromebook, you'll need to do it that way. If not, you can put everything in a folder that you know if you're on a PC or Mac. So the first thing that you do is find the mean of the price data. So if you look at the L7 data, we're going to have price, clothes, Cone City, Ice Cream Shack. There's a bunch of things we're going to be looking at. So if I found the mean of that, it'd be 23.69. And then what I do is just put that in the whole column. And then I take my 23.69 and then I take each of these numbers and subtract it. Now you can use R to do that as well. So I can do the difference would be the price minus the mean, then type in the difference. And right here, I have my difference numbers. And then there's some NAs listed because not all of my columns are equal. So if you look here, some of these are longer than the others, which is creating these NA numbers because R will assume that everything should have 19 entries. So what you do after that is we need to find the square difference between the value and the mean. So after we found the difference, we just square it. So the square difference is that to the second power, again, so you can list that. And then after that, you find the sum of the square difference. So I had to put this na.rm equals true to remove the na values. And then you divide by the length minus 1, or there's 10 entries, so 10 minus 1. And then that gives us the variance, which you can actually do directly. You can go variance of L7/price, NARM is true, and they'll give you that number as well. So that kind of gave us a way to find how variable is the data, how spread out is the data. And then most people actually do a standard deviation. So the sample standard deviation is found by just taking the square root of the variance. Now, I talked about sample standard deviation, and if you notice, it'll just say standard deviation. There would also be the possibility of taking a population standard deviation, but knowing all of the statistics or all the data of a population is extremely rare. So most statisticians just find the sample variance and sample standard deviation. So if you look here, you could have just done the standard deviation of that, which was 13.2. So it's important for the kids to be able to calculate those things by themselves. So they'll make some mistakes. Not everyone's perfect. And then to realize too that you can use technology to make that simple. Now we did a smaller calculation on 10 prices, but like let's say we're looking at 1,000 prices. Clearly we're going to use computer software to do that. No one's going to hand calculate the standard deviation for 1,000 things. So on here, we looked at the sample variance and sample standard deviation, and then the NARM equals true is needed when not all of your columns in your data set are of equal length. So now we're going to look at task 3. Well, what if you knew everyone for the population? How would you do that? Well, there's no actual way in R to do that. So what you would do is take that variance and standard deviation, find the length of it, and then multiply by n minus 1 over n. So what I'm talking about here, let me go through this and show you a little bit better. So if we did a sample of 20 freshmen to find how much they spent on clothes, we could find the variance of the sample, the standard deviation, and the MAD stat. So that is the mean standard deviation. Now, what if we said that was our entire population that we wanted to study? So what if we did the population of an entire class? So if we did that, we would need to multiply by n minus 1 over n to get the actual population standard deviation. So I just defined n as the length or how many entries are in the data set. And then we do the variance. We can multiply the variance times n minus 1 over n. So the population variance was 12,714.68. And if you look here, if I looked at what the sample variance was, it was 13,421. What you're going to see is the sample is generally an overestimate of the population, because in statistics, we don't want to underestimate something. We'd always rather overestimate it. And then to do, if we did the population standard deviation, again, multiplying by n minus 1 over n, we get 109.75. Remember earlier, our estimate for the sample was 115.84. So what you're going to do now is work on some of those hand calculations, finding the mean, the range, the interquartile, the standard deviation, the mean absolute deviation. So you can use R to do some of that. You could also make sure that you can hand calculate a standard deviation with a smaller subset of numbers, and then compare your answer to what you get with technology, and then also do that for our check for understanding.